increasing and decreasing functions. Okay, we're going to be looking at a functions graph, and our objective is we want to identify intervals on which a functions graph increases, decreases, or is constant. Okay, let's first off discuss what we already know. We know what a function is. A function is a relation in which each component of the domain, each input value, each x value, corresponds or maps to exactly one component of the range or output value or y value. Okay. On an open interval, so we're always going to be using our open parentheses, okay? And we're going to be discussing this with our x coordinates. Okay, on an open interval using the x coordinates, the graph of a function is either going to be increasing, and if it's increasing, that means as you look at the graph from left to right, it's rising in that section or that piece of it. It's decreasing, which means as you look at the graph from left to right, it's falling in that particular piece, that section of the graph, or it's constant, which means in that section from left to right, it's a straight line, a horizontal line. Okay, let's take a look at a function, and let's talk about the intervals, and we'll use interval notation. Okay, so we open interval notation to do this. Okay, so here is example 1. State the intervals on which the given function is increasing, decreasing, or constant. So here we're given the graph of the function, and we're given the name of the function. The function is x cubed minus 3x, and it graphs like this. Okay, on what intervals is the function increasing, decreasing, or constant? And again, we're going to be using our x values. Well, as we come in from negative infinity, the function is increasing from left to right, and it's increasing all the way until it gets right here at negative 1. Okay, so it is increasing. Whoops, increasing has an I in it. It is increasing from negative infinity, x values. Negative infinity, this graph is increasing, increasing, increasing from negative infinity all the way to negative 1. And we're going to use an open because at negative 1, it's neither increasing or decreasing. It's hit a plateau. It's stopped. Okay. Where else is it increasing? Well, it hits a bottom here at positive 1. And from positive 1 all the way to positive infinity, it's growing, and it's slowly moving to the right. It's also increasing from left to right. So it's increasing from negative infinity to 1, and from positive 1 to positive infinity. And again, open interval, open parentheses or close parentheses, because it is neither increasing nor decreasing at x equals 1. That's why it's an open interval. Okay, and then between negative 1 and 1 on the x-axis, the graph is decreasing. It is falling from left to right. So it is decreasing from negative 1, again, open intervals, to positive 1. Okay, this graph, there is no constant. There is no place where between two values it is a horizontal line in this case. If there was, we would do the same thing. Okay, I want to again note those two important things. Okay, note the intervals are defined using the x values. Okay, from negative infinity to positive infinity. From negative infinity to negative 1, it's increasing. From negative 1 to positive 1, it's decreasing. From positive 1 to positive infinity, it's increasing. Okay, we're using the x values to determine increasing or decreasing. And number two, I've spoken to it. I just want to point it out again. We have open intervals, not closed intervals. Okay, so we're not increasing or decreasing at x equals -1 and x equals +1. That's why we have the open parentheses to indicate that.